Another property of exponents is born by thinking of this type of problem. Here's where we have 5x squared, that entire expression raised to the 4th power. So in this exponent right here, the base of that exponent is this 5x squared. The base of that squaring, or that exponent, is only the x. But let's start with this. What in the world does that 4 mean? It means 4 of those multiplied together. So I'm going to actually write that down. 4 5x squareds multiplied together. So it means that 4 of them. And from a previous technique, this means multiplication, and in there means all multiplication. So I can multiply the number pieces. So 5 times 5 times 5. So really 4 5s being multiplied. So 1, 2, 3, 4. So that's 625. Multiplied with how many x's are here being multiplied? Well, there's 2 here, 2 here, 2 here. Really just add those exponents. So we get 8 x's being multiplied, or that as our result. Now I'm going to stop here and take a look at this part of our process. What was happening here? Where did that 625 come from? It came from 4 5s being multiplied, and then the result here with 4 of these x squareds being multiplied. 4 of them. 4 of those guys, and I can write it this way. 4 of them. And so take a look here, what we see, the relationship between that 4 and the effect it has on the 5 and on the x squared. And so this 4 here can be thought of as applying to the coefficient and applying to this as well separately, and then multiplying the result. In other words, you could have taken 5 to the 4th and then taking x squared to that power there. So if we were to do that route, I mean, that would still give us our 625. And then look at what happens here. Something's happening with this squared and that 4, and the idea here is that well, that's another property which we'll get into, but just so you know, I mean, 4 of these x squared terms gave us an x to the 8th, and there's actually a multiplying there happens. I'll get that in a minute, but I just wanted you to see that this 4 here is applied to that and that. So this is another general rule. Let me write it right here. If I have an expression, 2 guys being multiplied, like 5 and x squared, I'll call them a and b, and I raise that to an exponent, then the exponent can be thought of as being applied to each separate factor in there, each separate factor. So that would mean a to the m times b to the m. Now I'm not a fan of this, but you can certainly use it. It's another property of exponents. I would say write out what that means here first until you get a hold of it, and maybe just take it to this step and then go straight to here. But I'll show you how we can use that here.